Okay, so these are the permission information RWX. Uh, you can see the 9 characters here: RWX, RWX, and R-X. Sometimes the whichever missing RW hyphen, RW hyphen, R hyphen hyphen. So that means hyphen or minus is actually not having the app permission to that kind of user. So first three it stands for the present user, that is you, and the next three is for your group. Okay, and next three, the second one is like a group or whichever connected to your group actually. Then next three is anyone else. So whole universe, not in your group, anyone else. So for example, you can see a first file, all subjects. It is having RW hyphen. So that means you are having access for reading and writing, but not having right for execution. And the same thing goes to the your group. And then anyone else is only can read. They cannot even write it. So it cannot edit also. Okay, so that is the meaning. You can change those permissions. I think you must have definitely studied this one in biocomputing. Can you tell me what is the command using for changing the permission? Anyone remember? Changing permissions of the file. You can't remember. Okay, thank you. But you heard, you remember that you studied? Okay, thank you. Yes, you have done. So CH mode. CH mode is an option to change the permission. Okay. So how to change the permission? We can give the number for changing the permission and 1 until 7. 1, 2, 3, 4, 5, 6, 7 for each one, each user and group and uh, others. Others mean anyone else in the universe. So the 3 digits we need to give. For user 1 digit, for group 1 digit, and others another digit. So what is mean by 1, 2, 3, 4? Okay, maybe we can have a plain text, or maybe we can try here itself. That permission. Just by creating one file permission. So 1 mean, so it will be just execution. So hyphen execution. That is 1. 2 is no rights for reading, but writing okay, no execution. That is 2. 3 is read. You can read, but no writing, no execution. 4. So you can see the combination of 4, where you can get 4, 3 and 1, isn't it? So that means read hyphen execution. That is 4. Read is 3. 1 is for execution, right? Read is 3 and execution is 1. So 4 is R hyphen X. 5. 5 is what? 3 and 2, isn't it? So that means R W hyphen. RWFN. Okay. 6. One, two, three, RWX. Oh, only 6 are coming now. Should be 7. Somewhere I lost it. Okay, let me try and see. Let us change the permission for all users. CH mode. Seven 666. Okay. Sorry, I missed it. So that is permissions. What I typed is not correct. So what is the correct one? Again, I'll cat permission. So now one is -X is correct. 2 is readable but not execution. Sorry, not readable. Again, okay. Okay. One is 2 is okay. Read, write, execute, right? Okay. So 3 is I'm doing same mistake again. Not used to teach by typing, That's why mistake. Okay. 3 is -WX. So because 3 is a combination of executable and writable. And 4 is the reading. Okay, read. But no writing and execution. 5 is read and execution. 6 is read and write and no execution. 7 is read, write, execute. Okay, this is the correct one. So the one mean only giving the permission to execute the file. 2 is only reading or only writing. 3 is write and execute. 4 is only read. 5 is read and execute but not write. And 6 is read and write. And 7 is giving all permission. So these are the numbers you can use to change the permission of the different files. Let's see here. You are having the molecular modeling. You are having a read, write, execute, and read, write, execute, and read, no, write, and execute to the others. That's what having permission. So I change to 111 to the molecular modeling. So that means it is only can execute, we cannot do anything else. So CLSL, see now the molecular modeling, everything is changed. -X, -X, and -X, because -X is the one, isn't it? So now CD, see LS, I'm trying to use, it's permission denied. So I cannot even execute a small command in molecular modeling folder. And let me try if I can create a file. Touch file 1, permission denied. I cannot create any files here in this because this molecular modeling permissions is not there. Only execution. I can just enter it, but I cannot do anything else. So cd dot dot, go back to here. Now I change it chmod 777 to molecular modeling. Now you see LSL. Now you can see everything is possible. Now go to the CD molecular modeling. Sorry, and create a file now. LS, it's not showing a permission denied, and mkdir touch file 1. It's created. So that is what. Previously, when there is no permission, it was not allowed you to execute any command and also cannot create any files. But after changing the permissions, you can do it. Yeah, similar way you can change the permissions like chmod 77 for user or user. You can have a read, write, execute. You don't want others to give a permission 00. So that means, so molecular modeling, so you as a user, you can read, write, execute, but others you are not giving any permission. So that's, so you can do anything. You can go to the molecular modeling and you can list down everything you can do, but others cannot do, whichever connected to your server, they cannot execute. So when you are working with a big server, a remote server, so you can do this kind of permission changes so that any other users connecting to your server and having access to the files, but they cannot execute. You can change the permissions that they cannot even execute, they cannot read, they cannot write. So you can play with those kind of functions. So that is mean by LSL, and what is meant by those permissions and how you can change the permissions. I hope you are clear. And then what we are going to do, ls L, we have a lot of files. So let's say we want to have whichever the file start with biotech. So if in case if it is so many files we have with the biotech, but you want to list down those. So ls, we can do biotech asterisk. So it will list down biotech and biotech 1. So that meaning of this asterisk is that, so whichever start with biotech, after that, anything is fine. You display. Okay. Same thing goes to, let's say ls bio and star asterisk. So anything starts with bio. So that means it will display biotech, biotech 1, bioinfo 1, bioinfo, biopython, biopython new. Yeah, this should display. Yeah, these are all displayed. See, and this also, if you want to have ls hyphen l bio should, yes. So the same thing in a long list. So hyphen l is a long list, but all the files start with bio. So these are all start with bio. So when you are for your directory is full of many files, and you wanted to locate, starting with some kind of information and end can be anything. So you can use this one. And similarly, we can use even ls hyphen l start with b. No need to have bio also b. So there is no, I mean, all listed the same with the bio. So here we have MBD, molecular modeling, and now let's try with ls hyphen l. Start with M. So we have MBD molecular modeling file, and even in the molecular modeling folder, there is called as file 1. All will be displayed. So like that, you can, that is called as wildcard character. So ls, you can use any wildcard character. So asterisk is one wildcard character. Another one is question mark. In order to show question mark, we need to create some more files. Touch biotech 3, biotech 4, biotech 5. Okay. If you observe here, biotech 1, biotech 3, biotech 4, biotech 5, biotech 2 is missing. It doesn't matter. So let us list LSL biotech. Okay. Before that, another one, touch biotech 2, biotech 11, biotech 12, ls hyphen. So now we have biotech, biotech 1, biotech 11, biotech 12, biotech 2, 3, 4, 5. Okay. ls long list biotech question mark. Question mark. This is also another wildcard character. If you enter this, it will display after biotech any one digit only it will take, any one character. So that means biotech 1, 2, 3, 4, 5. So it will not display 11 and 12. So if you put two question marks, it will display 11 and 12 only. It will not display 1, 2, 3, 4, 5. That means it is specifically mentioning that after biotech, something having two characters only to display. So others don't display. Or one character, one question mark mean one character display. So it is something different from asterisk. Asterisk wildcard is everything. Everything will display. Biotech 1, 2, 3, 4, 5, 11, 12. But if you are specifically uh, one character you are looking after biotech, so this is the one. you can use different ways, like B, bio, tech, right? Question mark, TECH. Okay. And one more character, that is digit. We put like this. That means after bio, 1, 2, 3, 4, 5 characters containing files. Can you guess what it will display? It will display not only the biotech, even bioinfo1 also it will display. Because bio, after that 4 characters and 1 digit is there. So all 5 it is fulfilling. Like that you can play a different ways. So okay, bio question mark 1. It will display bioinfo1 and biotech. Instead that we can do this bio asterisk 1. So it will display bioinfo1, biotech1, bioinfo11, because 1 also considered as asterisk here. So end with 1. So bio start with bio, end with 1. That is what. Anything start with bio, anything end with 1, it will display. Bio anything and end with 2. It will display biotech 2 and biotech 12. Oh, sorry, ls -l bio asterisk 2. So it will display 2, 1, 12. So anything start with bio and should be end with 2. So like that, you can use a combination of asterisk and question mark to display different files in your present working directory. That is about ls. Then we can go to the grep. So we have some information we created in some of the files here. Which file? Is it bioinfo? Maybe not here. Yeah, human here. Okay. Now I remember. Human, right? We created. Okay, human. Okay. So here, this kind of files you have, and you wanted to extract something from it, giving some information. Like you want to extract all the genes which are present in the plus strand. So use the grep plus human. So this is the syntax. So grep and give the word which you wanted to extract and human, and it will display only those the plus strand genes. Only 2 genes are there, plus strand genes and 2 display. And grep minus 2. So all the genes which are present in the minus strand, that is reverse strand, will be displayed. So as it is information is too small, so as a big files we can do, you can play and get more information. So let us see that we can add some information. 6, instead of gene I put protein 1. Protein 1. Then size, maybe 400 amino acids. And let's say this is a plus, and similarity maybe 80. 7, protein 2, and 500 amino acids minus 90. 8, protein 3, 50 plus 99. 9, protein 4, 600 minus 1. So now I appended. What I did, this is greater than symbol, added more information to the existing file by using appending. So that's what I did, and I added next another 4 lines to it. Now let us try with the same thing, grep plus and human. So what should be displayed? The gene 1, gene 4, gene 6, and gene 8. Okay, whether all will display or not, we'll see. Not all displayed. So only 1, 4, 6 displayed, not 8. Can you guess why? I purposely type capital, uppercase. So uppercase, remaining 3 smaller case, which we have given in the grep, it is displayed. It displayed, but when it is typed in uppercase, it is not displaying. So we have to give some other information to the grep. -I. Ignore casing. I stands for ignore. Ignore casing plus human. So now it displayed 4. Even the 8th line also it displayed. So plus, 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 plus. Similarly, grep -I, whichever stand. Hello. Okay, grep hyphen I, which will ignore the casing, minus and human. See, now the three of them are in a lowercase displayed, even two are in uppercase also displayed. If you don't use the ignore casing, only display first three of them. So that is stands for ignoring the case. So another one is verbose. Verbose mean okay. Before verbose, we can try with grep protein. P-R-O-T. P-R-O-T, human. What it will display? Only two, PROT1 and PROT2, because this is the uppercase and this is also uppercase. So grep hyphen I, ignore casing, PROT, human, will display all the proteins, whichever it is start with by. Sometimes you tend to have a uppercase, sometimes lowercase. So ignore all those things and display all the proteins information. So the similarly grep hyphen I, gene, human. So all genes is displayed in the human. Okay. Now the percentage. So percentage around 80 of the 80 are 1, 2 are there. 90 is 90, 1, 2 also there, and 99 also 1, 2. This randomly I have taken, but okay, grep any of these will take grep 99 human. So it display two of them. Okay. So grep 100 human, only one. Sometimes you may need to use the extracting the things by excluding some condition. So now you have 100% similarity is one gene, that is protein 4, and remaining all not 100%. So you want to have others other than 100%. You can use verbose, grep hyphen V 100 human. So this is V stands for verbose, that is the opposite to it. So that means it will display all the genes information except the 100. So this is the only 100. It will not display. See, so that is called as verbose. Grep hyphen V 90 human. So other than 90, it will display 99, 98. Grep hyphen V gene human. So all the proteins will display, all the genes will not display now. I mean, gene in the sense nucleotide sequence will, all the proteins annotated one, it will display. See, proteins display, verbose. Grep hyphen V verbose protein. See here, you can see different. Some proteins also will display. See, prod 3, prod 4 displayed, because that is uncapital, that is uppercase, but PROT, what you gave in a grep, is a smaller case. So how to exclude even the uppercase one? Grep hyphen combination of it. Ignore and verbose, IV. Then prod human. So now what will do? It will ignore the case and exclude the capital prot 3 and prot 4 also. So it will display only other than proteins. That is how you can use multiple options using hyphen I and V. And you can use what are the things we learned? I, V only, right? Okay. Another one is character. Grep C gene human. How many of them? It will not character. C stands for count. So how many of the genes, how many of the information is having gene information? So these are 5, right? Gene 1, gene 2, gene 3. How many lines? 5 lines, right? 5. Grep -C stands for count. So grep -C prot human. How many? Prot, it will be only 2 because you are not ignoring the case. So grep ignoring the case and count prot human, it will be 4 because prot 3, prot 4 also. And grep ignoring the case, verbose and count prot human. So it will count all the genes. That means 5. So ignoring the case of the prot, that means prot 1, 2, 3, 4. Verbose, that means gene 1, 2, 3, 4, 5, it will uncount. That is 5. I hope you are following. So that is the 3 options. Then, okay, another one is start with and end with. This is also interesting. Okay, before that, we can try to take a bigger file, something CD, where we are. Okay, year 3. Bioinfo. CD year 3. Yes. Okay. Cat protein. There is one file called proteins in some of my research area. We extracted some proteins, list it in a CSV format. Enter, it will open. It's a big file. It's just go through and just give you this information. Big file. So maybe let us see head of this file. So it is how it looks like. Okay. And how many lines are there? How to know? NL, same the file name. It's having 3,514 lines are there. So that's why you cannot see full file. So you can use head and the file name so that you can see that at least 10 lines of first 10 lines. What is there? So you can see some of them are having this is the genome ID accession number, and this is start codon, start sequence and the end sequence, and this is the plus strand or minus strand. And if it is any gene ID present, it will give gene ID and the locus of it. And this is the tag of the particular protein, and what is the size of the protein, and any information of the protein, and the protein name. So this is the annotation we call as. So all this annotated information of this genome is present, proteins are present. So some of them are all are unique proteins. but I want to see something commonly using one common. Many of them are ribosome proteins you will get. So what I do, I will take ribosome, okay, as a word to search something. Grep, ribosome, and this file name, proteins underscore whatever. Oh, there are so many lines, right? How to count how many of them? How to count? Grep hyphen C, ribosome, and this file name. So now you'll see 17 are there, 17 lines. That's why it was very fast. So see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, 17 lines are 17 genes, which are 17 proteins information, which is having ribosome. But they annotated differently. 30S ribosome, another one, that ribosome maturation factor, ribosome assembly RNA. There are different proteins, but which are having ribosome name as a common. Okay. So any other thing we can commonly can see is maybe plus we can see grep plus and proteins, this one. There are so many, and again we just count it. We don't know exact number. Count it. So 1693. So out of 3500 something, 1693 of them are in a plus strand. How many of them are minus strand? So how to know the minus strand? So you just verbose it. V and count whichever not having plus. So 1821. So total it is going to be 3500 something. So plus strand is 1693, minus strand is 1821. See how easily you can get the information immediately if you know exactly how to extract the information. And yeah, so yeah, maybe some heme proteins are there. Grep, heme. How many? Oh, many. It's not only heme, they are having, it is also taking up hemagglutinin, all these things, heme, everything. So let us see. I never tried. Maybe we can try heme question mark. That means after heme should have only one character. It's not there. It is not going to work here like this, but we can have a different graph heme. So wherever HEM all displayed, how many of them? Count -C. 37 of them. Okay. So that is how you can use the C, V, and I. Then we can have to go with the start and the end. For this, we have to create some other files. Okay, let us create, because this file also not having any unique information. We have to create another file. Okay, I'm adding some other information to it. So here I will add, instead of the number, I will add something else like AA, um, again G, 11, so something number. So class. So similarity, yes or no, like yes. There is no number. Okay. AB protein 10 some number minus no. Okay. Like this, you have information. So some lines start with the digits, that is numbers, and some you start with the alphabets, and end with the different. This is the similarity percentages, and here just similarity is there or not, yes or. So ambiguous information is always possible uh, in your information files. So with this, oh, do you have any other class now? Hello?
No, sir.
Oh, okay. So why somebody logged into this Zoom? Okay. Is my voice is clear? Is it breaking?
Not really, sir. It's just fine though for me.
Thank you. Because somebody now you somewhere someone answering, it's not clear. I think Gia. Okay. So we can use whichever starts with where start with, this is the cap symbol, which is start with A and file name E1. So it will display A and A. I mean the first two, I mean last two lines, that is start with A. Or grep start with 1. It will display only the first one. Or grep start with any of the digit. So put 0 to 9, but that means any digit you want. So all 1, 2, 3, 4, 5, 6, 7, 8, 9 it will display. So like that, you can screen out whichever start with the alphabets or whichever start with the digits, you can filter it out. So the 1 to 9 all start with the digits. AA and AB start with the alphabet, because so we don't have much example of different start. That's why I'm finding different file to show you. Otherwise, we have to create it. Let's see if we can find something. P vulgaris also not all are here. One line only is a FASTA format. Cannot P pudding. Here all start with the UN only, so cannot have a ambiguity. So let me set some other file which can have different information. These are all starting with the numbers only. Okay, let me take this file, copy and put in your file. Yeah. Okay. So we have CGA, right? Cat GCA something. So it's having start with all our alphabets, right? Sorry, the digits. Okay. What do we do? Cat. This one and this one we can create as a different file. Let's put genome. Okay. So cat genome. It's having all information. Some of them start with the alphabet and some of them start with the inverted commas or quotes. So now we can try to have a graph. Start with 1. So start with 1 and genome. Nothing, huh? It is genome. So graph start with 0 to 9. Oh, it starts with CDS, not the number. Okay, it started with CDS. Okay, great. CDS, start with CDS. All are there. So that is the starting. End is with this number here, and this is also number. What about the grade? Start with inverted commas. Oh, it is taking different. It is not going to work. Correct. Those CDS. Okay. So verbose, it's working. So it start with this UN, inverted commas and UN. So if you want to count verbose, count other than CDS is 7,286 lines. When you want to count the lines with CDS, it's a 3,592. Sorry, start with, right? Start with. Yeah, same thing. All are start with only. And verbose or start with is the same. That is how you can use the starting with the lines, that is the cap. And when you want to have end with, so grep 029 dollar genome. So nothing is ending with the digits. Okay. Yeah. All of them, they're okay. Genome. Okay, I think we go with our own file is better, because that those files are having some hidden information there, so it's not working. So better go with that. Okay. Now here, grep ends with the digits. So 0 to 9 and dollar human. See, all are end with digits. It will display 99, 98, 90, 55, all. But these two not display because they are not end with human. So end with mean dollar. So whatever it is here, end with symbol is dollar and human. So like grep 0 and end with 0, human. So 80, 90, 80, 90, 100, all it will display. Let me add some more in human. Set protein 9 plus two. Okay. Okay. So now let us see end with alphabets. So grep A to Z, that means end with any of the character, any of the alphabet, and then we have to use the end with mean dollar human. So you can see the whichever S, no S. But thing is, when you put A to Z, it is all small letters only we have mentioned, A to Z. So in order to ignore case, grep hyphen I ignore, then A to Z dollar human. That means it will display even the ZZ protein 9 also, because S is the end with the capital S. So that is also included, because ignoring case and end with any of the alphabet. So these are all things. So if you don't want that, the end with alphabet, so IV, So all other things it will display. End with other than alphabets. Then so we have seen end with using the dollar, and start with is the cap, and grep you can use this the cap and dollar. What is the meaning of this? That means you start any line with the end. So that means starting is the equal to the end. That means empty lines. So empty lines we have one. So that's why it is displaying this one line. You see cat, human, there is one line is empty. Purposely I created. So this one line, how many? So you can count also. Maybe you cannot not only immediately display, count how many empty lines. There is one empty line. So you can append some more human, then make another empty lines, then you can make it. So cat, human. Now we have multiple empty lines, no information on it. 1, 2, 3, 4. So in a bigger file, you cannot able to locate where there is no information. You want to know exactly how many lines are empty. Grep, start with and end, and human. So it will display. And how many lines you want to count? -C, count the 4 lines. 4 empty lines are there. And if you want to display the human file, grep verbose human. What it will display? It will not display empty lines, but it will display all the lines of human. See, it will exclude the verbose. What we did? Start with an end. That means empty lines, verbose. So opposite, I mean, other than that. So human is having around 4, this file is having 4 empty lines. So all other than 4 empty lines, it displayed. This looks better, right? In a big file, maybe you have hundreds of empty lines, which you don't want to display for your analysis purpose. So you can just use verbose, this empty lines and file name. So it will display other than empty lines, and you can save this one. So the same thing, you can save into human 1. So without empty lines now. See, cat, human first I open, it will display all the empty lines also. Now cat, human 1, there is no empty lines. So you can, like this, you can, what you call, clear or filter whichever your unwanted information. Okay, so that is what we can use there. Then I think that's it. I think you can practice this. You can, a lot of examples you can create out of it. So many functions. Grep is a very big area. Grep alone you can write a big program. So that much information you can, that many functions you can use using grep. Grep is a very big area. So grep alone you can get a big book. So, but small, whichever in daily using, I mean simple using, I just gave you the information. And with this we can end the LineX command.